Hello friends, welcome to today's class for your IANN class. So moving ahead from the previous classes, we have started with your backpropagation algorithm. If you remember, please go through your previous video wherein I have discussed what is the requirement to study your backpropagation algorithm. So what all we have seen in the previous class, the need for the backpropagation algorithm, right? The first thing. The next thing is we are changing our signal function to sigmoidal function to some layers. Next very important thing is we have seen how the multiple layers are applied, and other very important thing what we saw was how to apply your square error. How is your epsilon calculated? Okay. Now to move ahead from that, we'll go ahead with the derivation. Before going ahead with the derivation, I would like to tell you that what is the procedure applied to update the weights. So remember friends, any algorithm you take, what we are trying to do, we are trying to update the weights so that we move towards a minimum error value, right? So therefore, in continuation with the previous class, today we will go ahead with the outline of the learning procedure. What should be my learning procedure? How I should proceed, right? That is what I'll be discussing as a first topic in today's class. So remember friends, this backpropagation algorithm works on your gradient descent based learning. Okay, there are two learning methods. One is error based and another one is gradient descent. Note out in both the methods we will be calculating your error, which we call as epsilon. So here also we will be going ahead with your calculation of error, which is epsilon, but the method which we will be using is gradient descent, right? So let us see what is the first step. So we have some 6 steps. Let us see what is the first step. So the first step here is to select your input, which is x of k. So from where I should select my input x of k? That is nothing but a pattern from the training set, which is tau, and I should give it to the network. This is my first step. The second step is what now? To calculate your activations and signals. Activations could be n number of activations, like we have seen in the previous class. We basically use your linear activation or sigmoidal activation. That is either linear signal or sigmoidal signal. And how do you decide these activations? Remember, this is not the case which we are used in your perceptron or LMS algorithms. Here we have 3 layers. Which are the 3 layers? Input layer, hidden layer, and output layer. So based on that, we will be selecting our activations and signals. So, and this has to be done in sequence. That is, first input layer, next hidden layer, and the third output layer. Okay. So for these 3 layers, sequentially, we have to select our activations and signal. This is my second step. Going ahead, the third step is to calculate the error, right? So this error calculation is very important, and this is done over all the output neurons. And how it is done? It is done by comparing the generated outputs with the desired outputs, right? Generated outputs are the outputs which you are getting. Desired outputs are your d of k, which you have already seen, right? Next, the fourth step is nothing but using this error which you have calculated in your step number 3. We will compute what should be my weight change, whether this weight change should be towards the positive end or it has to move towards the negative end, right? And remember friends, we have to compute this weight change for hidden to output layer weights. That is first one. Next, we have to also compute it for input to hidden layer weights. Remember, as it is a layered structure, the complexity is bit high when you compare with your previous algorithm. So therefore, this error change has to be computed for 2 times. Once, that is from hidden to output, the next time from input to hidden. If I want to calculate this error change, I should know your very important thing, which is gradient, which we will see in the upcoming classes. And you already know what is a gradient, how to calculate the gradient. And if you are still not clear, please go through the gradient calculation class or go through your vector calculus, wherein you can easily understand what actually is this gradient and how to calculate the gradient and all those things. Okay, so this is all about your step number 4. Going ahead, the next step you have is your step number 5. So what we do is we need to update all the weights in the network using your step number 4. That is, we use the step number 4 where you have calculated your error, and using that error we will be updating all our weights. So again, remember friends, if I want to update the weights, there are 2 steps. Okay. So my 2 steps are, which are the 2 steps? One is when we move from hidden to output layer. The other step is when you move from input to hidden layer. So these both weights have to be calculated separately. So if I want to calculate these two weights, so you have here the weight updation equation remains the same, that is k plus 1 k plus del. Remember this much only, that is k plus 1 k and del. It means what now? K plus 1 is nothing but the next weight which is to be decided. H and J are your subscripts which decides, which is nothing but your tells from which layer to which layer, right? That is, you can say that from hidden to output, so therefore H and J. So K plus 1 is the weight which is to be calculated. K is the present weight. Del is the small change in the present weight which you are making. So therefore we are given here del of W of Hj, right? So this is from hidden layer to output layer. The same thing is also to be done from input to hidden layer. So if it's from input to hidden layer, just there is a change in the subscript. Instead of H and J, we have made it I and H. So from here you can easily link I is nothing but our input layer, H is nothing but it is denoting hidden layer, J is nothing but it is giving your output layer. It is something like this. If I try to summarize it, it would go something like this. One second. Yeah, it would go something like this. That is I, our input is what now? I. Yes. What is hidden? Hidden is nothing but your from input, it is H, right? And what is output? From H, it is going to output, which is J. So remember this subscript, that is I, H and J. Input, hidden and output, right? So you will be calculating all your weights in this fashion, right? Then we move ahead and we repeat the steps from 1 to 5 until we get our error below a predefined threshold. That is, error should go below a certain level, right? So remember in your gradient descent learning, where as we have already seen in your previous classes, the weight changes are made in proportion to the negative of the error gradient. We'll calculate the negative of the error gradient. That is, the weight changes del of WHJK, which you can see in your equation number 1, and del of WIHK, which you can see in your equation number 2, must be computed from the mean square error. Remember friends, mean square error, which you have calculated already, which is nothing but your epsilon. That is, you will be calculating your epsilon, something like this. I hope you have already seen this term, epsilon. So we'll be calculating your epsilon. And how this epsilon is calculated? This is calculated by calculating your gradients, which is nothing but your error gradients. Those are nothing but dou of epsilon divided by dou of W, right? So this is dou of epsilon divided by dou of W. Then you add subscript to it. Either it would be what now? I, H if it is input to hidden, or it would be what now? Instead of IH, what you would do? You would take W of HJ if it is hidden to output. That's all. Okay. Now, another very important thing which we need to look after here is whenever you use your pattern representation. Okay. So remember, if you are using pattern presentation, then it is called as iteration, and if you are representing the entire training set, then it is called as an epoch. So this will be using a lot of times, that is your iterations and epoch. So this iteration and epoch are very important. So moving ahead, next very important thing is we will be calculating the gradients. So gradient, as I told just now, it is nothing but dou of epsilon divided by dou of WIH of k and dou of epsilon divided by dou of WHJ of k. Now, if I want to calculate gradients, we will be using your epsilon, and epsilon is as shown in the equation. You can see here it is equal to 1 by q summation of k is equal to 1 to q epsilon of k. Now, this error, when it is calculated, the weight changes are made, and this process is called as batch update. So remember, this is batch update. Similar to this, we have something called as pattern update. So let us try to understand what is pattern update. So you can, if I just calculate dou epsilon by dou IH of k, it is batch update. If I put a iteration k, then it becomes your pattern update. So you can see here, if I use epsilon of k instead of epsilon, then we call it as a pattern update. So this is in simple words, but to go into much deep, we can call it something like this. So you can observe here, we have an input pattern x1, we have an input pattern x1, then from x1 to xq, that is x1, x2, xq, all are given to a network which is nothing but n dash. Then using that, we'll be calculating our error, which is e. Okay, and then finally we'll move ahead and we'll calculate our weight change, using which we'll be updating our network, which is nothing but n square. So this process is called as batch update, wherein we have considered our inputs from x1 to xq. If I consider my in pattern update, if I consider x1, which is nothing but which is an individual input pattern, and if I give it to n1, and if I calculate e1, from that I will be calculating your w, then we'll come to n square. So this process is done for all the input patterns, that is from x1 to x2, then from x2 we'll be calculating n2 cap, then e2, then w, and again you will be calculating your n2 square. This is done up till for your x of q plus 1 until I get n cap of q plus 1. Then that n cap of q plus 1 is nothing but your n square. So this process is nothing but your pattern update. So friends, I hope you can find out the difference. In your batch update, we have considered x1 to xq, and in your pattern update, we have considered your individual inputs, that is x1, x2, x and xq plus 1. Okay, so maybe I'll stop it here only, because the next slide or the next topic which we'll be seeing is your derivation. So if I want to do derivation, it is a bit lengthy derivation, so I want your patience and high concentration. So this I will continue as a continuity in the next class. Thank you for watching. Thank you.